Dot. And as people spill in, I do want to get started here, but I'm Wendy Placko. If you haven't met me, I am the host of our Decarb Debrief presentations, and I'm also the Sustainability Program Manager here in Northfield, Minnesota. Beautiful, scenic Northfield, Minnesota that was covered in snow this morning. My bike ride was a little icy, but I made it. And we're really excited today to talk about electrical resilience with the wonderful Jared Markle, who is joining me today. Jared is such a cool and in-demand type of guy that he has to get his way back home on a flight. So he's gonna drop off about halfway through the hour, and then we're getting a little help from our friends. The wonderful Andy Hay is gonna help handle the Q&A for us. So with that, I'd love to introduce Jared. If you want to just say a few words about yourself to the group before we dive in, I would love that.
Yep. Jared Markle. I work in our Baltimore infrastructure group, lead part of our electrical design team. Been working at RMF for about 14 years in May. Excited to get started. Been doing electrical power pretty much since day one. So a lot of big campus stuff, and excited to share a bunch of what I've been seeing.
And I think electrical engineers are in high demand and very special people. So I feel honored to have you on the line and know that they're very hard to come by. Is RMF the only place you have operated in your career, or did you work elsewhere before you arrived at RMF?
Nope, I did internships at a couple other spots, but pretty much walked across the stage on a Friday, started RMF on a Monday.
We got a lifer on our hands. Love to see that. Cool.
Yep.
Well, I'm going to fire up our slide deck here. So just to give a quick overview to everybody, what we'll be covering is a little bit about the planning process. I think that this is super smart. How do we strategically electrify so we're not adding a crap ton of load to a system and make sure that we're as efficient as possible? Then we're going to talk about the upgrade process and what that looks like in design and construction. Then Jared's going to share a little bit with us about some resilience opportunities that happen in decarb electrification work, and then we're going to go to Q&A. So that's what we can expect for today.
Yep.
So with that, I love this graphic, this notion. When we are looking at electrifying in a decarb kind of plan, what we often see is this sort of thing. You want to tell us a little bit about that, Jared?
Yeah, so really, as we go into this world of people requiring, and states and the nation requiring us to reduce our greenhouse gas emissions and go into these decarbonized heating systems, what it means for us electrically is that every version of technology includes at least some level of electrical demand increase. Most of the time, it's really substantial, which is really great news for RMF, because that means that it gives us the opportunity to replace campus distribution systems and even the opportunity to replace some campus substation level work.
Awesome. And what does that look like when you are doing that sort of upgrade as a general note? Like what do you see a lot that needs replacing on these campuses anyway, and is a cool opportunity?
Yeah, so what you end up needing to replace there, and we'll talk about this as we get through some of the planning, you'll see it. It's a 3-level kind of tiered approach. You have your local to the building electrical demand increases based on what kind of equipment you have dispersed out amongst the campus. You have your electrical distribution feeders across your campus, usually operating at medium voltage, that will go over their capacities and they'll need replaced. That means you're ripping up campuses and putting in a bunch of duct bank, putting in new services to buildings. And then the top layer is probably the most difficult one to wrap your arms around, just because it includes the utility. So most of the time you need to look at increasing, sometimes doubling, tripling, quadrupling your utility capacity to the campus. So working your way through interconnect agreements, working your way through service upgrades. I mean, we're to the point where we got like the cell phone numbers of the engineers at a bunch of these local utilities up in the Northeast. It's been a pretty cool evolution over the last couple of years.
Yeah, and I definitely am familiar with all the duct bank work. And you're at Dartmouth right now. We've got the Dartmouth map in the background here. Jared's joining us live from the Hanover Inn, where he was talking about electrical work this morning with that client. So, okay, how do we work to try and quell some of this load growth? You know, some is going to happen. It can't be avoided. So I'd like to bring back this idea that Kristen actually introduced in our second Decarb debrief, this idea of the coefficient of performance. This is the official science equation of COP, but I like to think of it in general as efficiency if I'm not being as brilliant as our engineers with the math at the moment. And so I just want to reiterate that the higher the COP on a piece of equipment, the more efficient that technology is. I will bring up this graphic that we showed in the past that kind of shows, okay, for how much you get in, how much do you get out? And so this is starting to give this sense of, okay, if we just switch to an electric boiler, you're going to get as much heat out as the electric you put in. But if you start to think about some of these other decarb technologies that happen to only work with a hot water system, so there is a little bit of a catch, though air source heat pump, I guess, can be either way. Then you start to see a lot more return on the heat that is produced based on the electrical usage. And Jared, you have your own cool way of walking through this that I want to give to you.
Yep. So this is kind of the cheat sheet where it's how you relate electrical into all these large campus decarb plans. These are just a couple of numbers to give you scale. So if you are replacing 100,000 pounds per hour steam boiler, if you do it with an electric boiler, you just added 30 megawatts to your campus. If you do it with an air source heat pump, then you have that because they're a relationship like that. So you end up with 15 megawatt increase. And then if you start going geo exchange, ground source, water source, you start getting into the limiting it even more. In this case, we use a conservative COP of 3.5 to get down to 8.5 megawatts. But really the important thing to know here is that every one of these technologies does result in an electrical increase to your campus. And in a couple of slides, we'll show you kind of what that looks like on a campus grid.
I love this because we're starting to put some numbers behind it. I think it's still a little bit abstract in this version of the graphic, the one from before. So when you start seeing, okay, your 30 megawatt load from an electric boiler is going to be cut in half with an air source heat pump, that's really something to note. So I love that. All right, tell me a little bit about this. I think this is continuing that idea of let's look at some actual numbers here.
Yep. So here is what this looks like when you look at real campus loads. These are a bunch of campuses up in the Northeast, Williams, Brown, SUNY Oneonta. These are all campuses with, I'll call them relatively low electrical existing peak loads. You can see Williams, for instance, is a 3 megawatt peak load. The addition of electrifying their heating system with air source heat pumps, for instance, that is 6.5 megawatts in addition to their 3 megawatt peak load. So you're 3 times what their current service is. And we're working through with National Grid now what that looks like. And in a lot of cases, it looks like a new upstream substation that might take 7 or 10 years to build. And you got to plan out how your program kind of extends from one spot to the other. We just talked about that with Dartmouth this morning in a conference room and 2 buildings away. As we transition from steam to hot water at Dartmouth, what does that mean for a temporary electrical service? What's it mean for permanent electrical service? How do you factor in the fact that we're putting in 13 megawatts of diesel generators that have a 2.5-year lead time? And then how do they all play together? So really, you just got to realize that electrical is a big cog in the wheel in a lot of these plans. And once your clients realize that, it ends up being an opportunity for RMF to be the glue that kind of holds the various parts of an upgrade together. Because you might have one engineering firm that looks at the new geo plants that go on a site. You might have another engineering firm that goes through and looks at individual building upgrades. You might have another engineering firm that looks at your thermal or distribution, but electrical has a piece in every single one of them. And from what we're seeing, people tend to like having one electrical engineer do all that. So it gives us a really nice opportunity to be a part of the team.
Keeps you a little busy too, huh?
Yep.
I really love this idea of, again, comparing this COP and what that can do to our loads and what the actual capacity is at that specific location. Can you walk us through this?
Yep. So this is part of an electrical master plan that we did. And this graph shows how all of their various growth initiatives reflect in their campus load growth. When you were looking at electrical master plans, even just 5, 6, 7 years ago, you really wouldn't have the red and the dashed red boxes as part of the plan. You would be growing with additional buildings, you'd be growing with building renovations, maybe you're adding a new lab. But now you'll see that these heating system upgrades, they really do almost dwarf some of the other electrical load growth you can experience on a campus. The dark red shows what they would be doing on their centralized system, and the dashed in red shows what they would be doing with their buildings not connected to the centralized heating system, but connected to the centralized electrical system. So these are just individual buildings that are getting upgraded. They aren't even getting a district approach, but it still affects kind of your district electrical system. And this is for air source heat pumps at a COP at 2.0.
Yep. Yep.
The next graph, this shows kind of immediately how much that reduces when you go to a COP of 3.0 for looking at ground source or some sort of geo exchange. Since we were already over the firm capacity of the system, which is the dashed black line, what firm capacity means is that that is the capacity that you can reliably kind of count on in the event of losing one item in what you're looking at. In this case, it's losing your largest feeder in a set of feeders. It can be your largest boiler in a set of boilers, largest chiller in a set of chillers, but that's generally how you look at firm capacity in an overall system. But here, every single one of them ended up kind of breaking the bank, requiring substantial upgrades. So what this ended up showing was you have to do a big electrical upgrade anyway. You can kind of take that off the table and start focusing on what it looks like in buildings and in other fashions.
Is that sort of a common occurrence from your experience? Does that happen a lot where electrical can operate a little bit more independently in the project?
It really depends on your system.
Cool. Well, there is another way that we can look at this. I really love this this diagram. Would you walk us through this?
Yep. So Andy Jones and his team put this together for our electrical master plan at UMB. That came on the heels of a giant electrical upgrade that we did at UMB. You'll see a few pictures from that throughout the slideshow. And essentially, this is the existing load that you see across the year. If you click, you'll see that if you go with ground source or water source heat pumps, it essentially does nothing to your electrical load across the year. If you click again, you'll see what it does with air source heat pumps. So now this is a phenomenon that very typically happens in these campus distributions where your winter peak load generally ends up matching your summer peak load in the Northeast. When you look at decarbonizing your heating system with air source heat pumps, it seems to just happen this way at most universities. So what this means is that your electrical system from your utility probably doesn't need to be upgraded because it can already support that peak capacity in the summertime.
Mm-hmm. Mm-hmm.
Then if you click again, you can see how electric boilers just typically destroy electrical systems. They are orders of magnitude above what your existing peak load was. There are very few places that are set up for this right off the bat. UMB happens to be one of them. We're working on a project right now with Vicinity to look at a 9 megawatt electric boiler that would serve UMB off of UMB's electrical system. So if you have the electrical capability and capacity for this, it's a easier option a lot of times because you normally don't need to do work within your buildings. You can stick with your steam system that you already have.
Right.
So it's definitely got its trade-offs one way or another. It's not always being the best neighbor with your utilities. Like if every single person went out and did this, I mean, you can think about the impact that would have on your local utility companies. So we almost view this as like the nuclear option, like on a lot of these jobs.
I just wanted to point out that it's really interesting to see like these winter loads, you know, in the initial options, in those higher COP options, are pretty minimal, and then all of a sudden your winter load is very large. Do you ever see an issue with that from the utility, like the fact that they're not, well, I guess I don't know the answer to that in general, but like, does the utility normally see a lot of demand in the winter time for electrical, given that
that's a good question.
Yeah.
So a lot of, at least in the Northeast, a lot of utilities will have a winter peak and a summer peak that they can promise you, and they normally have a lot more room on their winter side. You're going to see that flip or equal out in the coming years. Like there's a lot of utilities that'll say you have 10 megawatts of capacity in the summer and maybe you have 12 in the winter. So now I think what's going to end up happening is you have 10 and 10, or something similar.
Yeah, it's interesting. Okay, great. So thanks for going over this. I want to then just start to dive into, okay, so if we've picked a system that is going to be hopefully a higher COP, a little bit less of a load, what does it look like when we are thinking about upgrading for a specific client? And I think the biggest thing, I'm learning so much about this as a result of working alongside you on Dartmouth of just these utility negotiations are really important, and I'd love to hear your perspective on that.
Yeah, what we're finding is that at a lot of these universities, before you could go into these negotiations with utilities, kind of as a project starts, or generally the utilities response, if you did try and bring something up early on, is, well, let us know when you have a work order, when you have a real job. Now we're to the point where the upgrades required to serve some of these campuses are so significant that they're like, can you please tell us what you want to do in 10 years? And they still don't treat it like it's happening, but they at least start the planning process. And generally with these, you end up with a 6-figure charge from them to do a 9-month to 1 year long study where they look at what your upgrade does. And then at the end of that study, you figure out what you can do with the data they dump on you. And the data they dump on you at the end could legitimately be, we can't serve you that for 15 or 20 years, and you got to pay $10 million to us to get it. So
Do you see a lot of the utilities in binds because of the greening of the grid, like the requirements on this? I guess this might be a good segue in terms of some of the research that has been done in the past.
Yeah, so we tasked 2 of our interns, Hannah Klein and Shaneri McLean, on going through and doing a grid readiness study. This was a kind of monumental ask of them because what they looked at was they evaluated what different goals the states have. We started with the ones that we work in, and then we just kind of expanded it to a whole bunch more states. They really took it and ran with it. It was a great project. And we started with what the state's goals and legislative requirements were. Then they looked at what are the different utilities doing to kind of get out ahead of this. They are looking at what are the different regional transmission operators requiring of the utilities, and then also looking down at like what are you doing at like the state level. They're in the process of providing grades for the various regions and the various utilities, that if you have a utility that is in a state that has really stringent requirements, but they also have really high kind of goals and plans in place to support, then maybe they get a B or an A because they seem to be aligned. If you have a state that has really high requirements and the utility is not even talking about upgrades yet, they might be a C or a D. So we're working on a way to kind of qualitative or quantitatively look and grade these. And like I said, they've both done just a fantastic job. And we're to the point now where they're both coming online full time for us in the next, Hannah starting in January, Shaneri starting in May. So we're really excited for them to kind of continue working in this.
Awesome. Well, shout out to Hannah and Shaneri for that work. That's super cool to see. And that they'll continue it in their careers here. All right,
Yep.
so this walk me through this idea of when you're actually going to be upgrading a switchgear. I believe this graphic is telling me about that, but I don't know how to read it. Walk me through.
So what this graphic is showing is at UMB, we did a master plan to go through and identify what type of electrical project would be required to serve their updated campus. And the outcome of that was we would put in 2 match switching stations, one in the north and one on the south side of campus, red and yellow. And they would each have 4 separate utilities coming in from BGE, from 2 separate BGE utility substations. And then we'd have brand new campus distribution throughout the entirety of the campus. What you see in green is their generator plant that we've added 1 2-megawatt generator to, and we have plans to add another 2-megawatt generator there. The blue is, we'll call it the central hub of where all of the generation ties together. So we have a couple of other building generators that we're pulling in. So it really is a campus that has a full kind of state-of-the-art switchgear control system their operators can view the entire system from all three locations. It really gives them a seamless way to kind of deal with that level of power that they have on that system safely.
Got it. And in the past, they didn't have that much kind of load to be managing, and so maybe didn't have this kind of visibility requirement that you're offering here.
Yep. And this job enabled our clean energy master plan for the campus to say, hey, you have a lot of options here as you keep growing. So
Awesome.
this one had a lot of forethought on the RMF side, which was really great.
Super cool. All right, so let's look at this next one. So this was taken from a past presentation of yours where we were just wanting to group together some things that you think about when you do distribution design. And I thought that these were all really good points. Can you walk us through this?
Yep. So really what these distribution jobs give us the opportunity to do is work with our kind of all-star internal civil team. I mean, they have a lot of, I'll call it expertise, a lot of what they bring to these designs that you don't really see from a lot of our competitors. And when you kind of get into these locations and you get in an interview and you can put up some of the work that some of our civil folks do, Steve's group, Elizabeth's group, John Williamson, it really kind of is our differentiator in getting a lot of these jobs, the whole way from looking at how the duct bank is routed through planning out how that works on your site. So it's really a nice kind of hand in glove between our electrical and our civil teams.
And most duct banks are literally just like a big old pipe that is run with other distribution usually, or are you finding that you often have to trench and bury your own distribution for duct banks? How does that usually play out for you?
We are usually trenching and putting in our own duct banks. We try and
Okay.
align them with other campus initiatives when we can.
Yeah,
Elizabeth was just talking to Dartmouth upstairs about that as well this morning.
yeah.
And what you end up finding, like when we were at UMB, we were crossing Baltimore City streets in the middle of downtown with 32-way duct banks at certain spots. Like it was a huge challenge, and it was really interesting to see how that all worked out.
How deep were you going in that particular job? Were you able to go under the street, or did you have to like reroute traffic and things like that?
We did not have the opportunity to do any kind of like boring under the street. There wasn't
Yeah,
enough
okay.
room for any kind of pits for that.
Yeah.
So they had to excavate out, come up with full maintenance of traffic plans that were approved by the city. Steve Pollard led a whole lot of that initiative, and I mean it's definitely been interesting. We've been digging up that campus for probably the last 3.5 years now. Still have another
Yeah.
phase to go.
Yeah, so that speaks to your planning of site logistics. That's super important as you do the work. And then I think this is a good little preview into our talk about resilience, but starting to think about how we reroute power temporarily. Can you give just a quick high level overview of that?
Yep. So really it is about determining where your existing assets are. Um, our group is fully trained in going and doing manhole condition assessments, looking at how feeders are routed throughout a campus. And then we work with our planning crew to figure out how much capacity you have available. And then you look at all the pieces in front of you on the chessboard and you figure out what's the best way to kind of support this project through construction, knowing that you have these crazy electrical lead times to deal with and just a lot of logistics to deal with on the site side.
Definitely. Cool. All right, so just talking about that temporary power, this is a diagram showing a way that you've managed that for a client. Is that right?
Yep. So this is at UMB at their School of Pharmacy. The most important point that you need to understand when you're kind of putting in temporary power plans is it starts with planning. You identify with the campus, you get all the right stakeholders in the room, you let them understand that there's going to be big gray boxes sitting outside. You let them understand that there's going to be things that need to be operated externally from during bad times of year, during winter, during cold. And then once you have buy-off from everybody, you make sure that you adequately capture it within the bid document so it's not a change order later, and then you execute it when you are in construction. In general, from what I've found, most contractors take our temporary power plans as suggestions in a lot of cases, and then they normally will work with you to come up with a way that they want to kind of take advantage of assets they may own. They might have a
Okay.
temporary transformer sitting in their shop. They might have a temporary generator in their shop that they have something available that they can help the project out with, and then you kind of work with them to figure it out.
So something
But
like this kind of tees off a conversation with the contractor.
yep, like in this one specifically, we got rid of the temporary generator and they had a transformer at their shop that we ended up putting in and connecting it right to the campus medium voltage system.
There you
So
go.
there's always different ways to kind of look at it, and just kind of being a team player with a contractor helps. But you can only put yourself in that position when you put sufficient amount of cost in the documents for them to horse trade with you. So
Yeah. But let's jump to talking about resilience a little bit more.
no
Um,
problem.
and so I think one important piece is backup generation is really emerging a lot as a decarbonization goal because outages are more common in cases of severe weather or things like that. So can you talk about that a little bit?
Yes. So normally the backup for your heating systems is you got gas and then maybe you have oil or something as the backup. Now that a lot of these campuses are looking at electrification of their heating systems, they don't want to hear that if you're at Dartmouth and it's negative 10 degrees for a week straight, that you can't run your heating system because your utility went out.
Mhm.
So that's leading to a lot of campuses evaluating full campus generation. There's a balance there of kind of here on the second bullet point of you still are going to have distributed generation in most cases. You're still going to have life safety generators at individual buildings. And there's smart ways that you can utilize that distributed generation. For an example, you can have it where your main generators, your standby generators for the campus come online and a signal goes through your campus BAS or BMS system to tell all your distributed generators, hey, stay on generator even though you see normal power back because the normal power is your standby. That's a way to leverage a ton of existing generation to kind of maybe help minimize the amount you're putting in.
Yeah, yeah. And it's so interesting to think about those trade-offs of like in an emergency, the utility goes out. Maybe you in the past designed a dual system, that
Yep.
went to natural gas or something like that. But now, we are going to a generator, which is often diesel, fuel, oil, that sort of thing. But the fact that it's powering this higher COP system is still a better carbon trade-off. So to me, there's a little bit of like we're still going to use fossil fuels in the case of an
It
outage,
is.
but it's
And that's
a smaller level, I guess, if
and,
I'm
and that level of thinking has been evolving from what I've
yeah.
seen. So if you go to like an IDEA conference or something like that 3 years ago, every single person there is getting up there, your Princetons and your Stanfords, and they're saying, we are going to go off of everything, no gas on the campus, all electric. And then the next year they come out and they're like, well, I mean, we're gonna have a little bit of electric. We're gonna have a little bit of gas somewhere. We're
Yeah,
gonna still
yeah.
we're gonna still keep our turbines operational, obviously, and we're still gonna do this and that. And now at the very end of it in the last year, now a lot of these are getting built and some of the early risers are starting to settle in and get operating time. Every one of them are getting up there and talking about how they still have condensing boilers in the background and they have
Yeah.
thermal TESs everywhere for hot water. And it's been interesting to see how it's evolving and how it doesn't necessarily have to be electrical backup. Like it's okay to have gas as a backup for a very small
These are
portion of it.
emergencies. They're a very
Yep.
small portion of your load for a year. They're
Yep.
very unlikely, hopefully won't happen ever, but it does seem to me that, yeah, we do need to draw a line in the sand somewhere.
Yep.
And personally, I always want to push towards less fossil fuels, but if it, at what cost all of a sudden? So
Yep.
I think, yeah, I think that's
Yep.
great to hear that this rationale is coming, and I imagine that's part of the place that we are in the industry of people are actually building these systems
Yep.
instead of just talking about them, and they're like, oh, we get it now. Of
Yeah,
like
we're going out of the ideal world and into
exactly,
reality. And there's a bunch of engineering and utility directors out there at these campuses that are like, well, I need to give, my job is to give reliable thermal systems to my campus. I can't do that without X, Y, or Z.
Yeah, and we're talking about campuses might have medical portions, that's saving lives. Campuses that have research that could be lost, they're not going to sacrifice those things. So it's our job as engineers to give them systems that will operate in those emergencies. So cool.
Yep.
Great. All right, so last, and I'm keeping an eye on clock for you, but very last thing I want to walk through is this cool example of battery storage that you offer. This is Rutgers, is that right?
This is Rutgers.
Yep.
They have a large solar initiative on their campus. I mean, you can see here they have over 8 megawatts installed right now. They're adding more. They're experiencing a phenomenon where their solar fluctuations as the day moves from the sun going out, from clouds going over, is actually disrupting their own campus cogen system. And they
Oh,
have a lot of requirements with how many times they can restart that throughout the year. So they contracted us through a company called Ice Tech to do a study to look at battery energy storage. And what we came up with was an 18 megawatt hour system. So on the next slide, this is kind of, let's go one more. So on this slide, this kind of looks like the system that we put together for it at a high level. There's a number of battery modules with space to go to the future, which would be a 22 megawatt hour system, which is pretty cool. And then they have their inverters that feed into their step-up transformers to tie into their campus medium voltage distribution. We were hired really for the left part of the screen, and our role evolved to allow us to help get a look behind the curtain of the battery energy storage system. And now we're trying to apply these at a couple of other places, kind of here up in the Northeast in Rochester. And you're starting to see these pop up more. And a lot of people don't, a lot of clients don't understand how batteries are appropriately applied. So we do have some pretty good folks up here that a couple of pretty good client contacts that we can put anybody who has questions with in charge of
nice.
and or in touch with, and that will help to kind of get the right folks in front of the clients. There's a company called Stark Tech that we use a lot that we have a pretty good trusted relationship with that can help out with questions.
Solar is such a challenge with clients in education because I feel like at the end of the day, RMF is a very responsible company. We're always going to design for meeting the load needs, and I find
Yep.
that like sometimes it can be it can be easy to overlook solar as a generation option when there is this problem of it's only useful during the time that it's happening.
Yep.
So like what you were saying about their cogen was browning out or some kind of issue was happening because a cloud passed by. And so people don't think about the fact that you need this consistent flow of
Yeah.
energy in order for the systems to stay operational. So that's where battery storage comes into play. And I imagine there's a lot of change rapidly in terms of this technology and how those systems are improving both in cost and operations. Would you agree with that?
Yeah, absolutely.
Yeah.
And just one thing that we kind of preach to clients is solar is not a reliability increase for your campus. Batteries typically are not either. They are
Yeah.
usually operationally dependent and financially driven.
Yeah.
So there's never going to be a time, at least in the current technologies, where somebody can say, "Hey, instead of having a utility come in for our increased service, can we go with batteries?" I don't think the systems are there yet. Maybe they will be
Yeah.
one day, but that's certainly something that if you hear clients saying that, um, it'd be good to educate them that because you never know, like you don't know if the need is going to match the availability. And it's just the way the two systems are. One's dependent on sun, one's dependent on charge. And unless if you can really align the demand versus the charging for a heating system, I don't see them as being a replacement for a second utility feed or a generator.
And it's just a huge challenge because solar is the first thing that people think of when you say renewable or a
Yep.
decarb kind of plan. And it's the cheapest option for anybody to implement because there are so many easy ways to get incentives and the technology has just come down a lot in price. But in terms of that reliable flow, that is that thing that doesn't quite add up to people, and it's a big challenge for education from what I've seen. And so it's hard. We can't just like poo-poo solar. It has its place, but it can't be a reliable source. So anyway.
Yep.
Okay, well, I see that it is 12:38. You have been so generous to give us a few more minutes, Jared, but thank you so much for your time today and walking us through these slides. I'd love to give you an opportunity to get on out of here and get on the road. We will still keep the session open for Q&A, but I just want to thank you, Jared, so much for sharing all of your knowledge with the team, and it will only continue to increase from here. So thank you so
Yep.
much. Have a great
Nope.
rest
Thank
of your
you.
day.
You too. And if anybody has any questions, feel free to Zoom chat or email me, and we can get on the phone and talk about them.
Andy, I would be curious if you have anything to add from today's conversation, based on what you heard or trends that you're hearing right now. Would love to hear your 2 cents.
Not too much. I mean, Jared, I will say is I'll say our foremost expert on the electrification side, certainly dealing with the mechanical um, aspects and conversion and how that relates between steam to electric and so on. Um, he's been an integral part of the team. Certainly, all of us, as well as the folks in North Carolina that deal on the infrastructure side. I mean, we're all familiar with the resiliency and the reliability concerns that come up, and we're continuing to evolve with the different technologies that are coming into the market to how we can couple them together and create the best solutions for the clients. So
Absolutely.
it's always an evolving process.
One thing we were talking about is that electrical work is just keeps on coming, because no matter where a client is on their like decarbonization roadmap journey, figuring out what kind of portfolio they're going to have, they know that their electrical systems need upgrading because demand is increasing no matter what. So I'm just really curious to hear your thoughts on that. Of, uh, this side of the business is just going to keep getting more and more action, right?
Well, I think it's twofold. I mean, there certainly is the increase in demand that's going with the newer, more energy efficient buildings, which is a little bit contrary, as you say it. But we're seeing that the energy efficient buildings are actually drawing more electric because of the
Right.
different technologies.
Yep.
But the other phenomenon that is happening is you have to go back and you have to look at your history a little bit. And, a lot of the boom in college and universities, a lot of our market that we play in happened after World War II. It happened in the 50s and the 60s. And
Absolutely.
a lot of these
GI Bill.
campuses have continued to build up over time. And maybe they've gotten a restoration or an expansion of their system in by now. But we still come across universities that have existing equipment from the 1970s that
Mhm.
is now coming to, obviously the end of its useful life.
Right.
So they're trying to look at solving the maintenance problem and the operation problem in conjunction with added growth, electrification. So that's really, going to continue to be a driver in the industry, um, as time goes on.
Yeah. Great.
Sure. So I found this conversation very interesting. I'm wondering how you approach these college campuses, which essentially sometimes you're doubling or tripling their electrical demand. And, obviously that's going to be a huge sticker shock for them. And I don't know, how do you keep that from becoming a deal breaker right off the bat?
That's a great question. You want to take that, Andy?
Yeah. So, I mean, it's always a careful balance, Dennis. But you and I have worked together quite a bit over the years, and the biggest thing that we as RMF tend to do is, you know, put the harsh reality out there, no matter what, and whether we are presenting it or they find out late in the game. I mean, the simple matter is, okay, if you want to go with some of this technology, if you want to get off of steam or you want to get off burning fossil fuels and go with electrical, this is what is coming with it. It's not a simple, proverbial flip of a switch. The power needs to come from somewhere. So, we put it out there, and a lot of times, some clients are understanding of it, and I'm not going to say they're all prepared for it because most of the time they're not. But they need to understand what they're walking into, and it's not a simple conversation by any means.
I think it's a great question, Dennis. I think client education is such a huge part of this work. And from a business development perspective, it's really tricky because I used to work in no form of technology, and people don't understand, like, have even a ballpark or scope of the cost of change in this particular scenario. So we find ourselves scoping out work and handing off a really big price tag and, getting a lot of sticker shock from clients. And that's part of the education process. I think the more that we can do to throw out a ballpark of, like, this is what you're looking at to really aggressively take on these goals that you've set, then the better off that we'll be in this two-way conversation. But it's a really hard thing. I will say too, to just harken back to what Jared was saying of, doubling, tripling loads with some of these technologies, the important thing is to make it clear of what your options are. So, a double or tripled load is often from using a certain kind of technology of, if you are just switching to electric boiler. And that makes your life easier, client, because suddenly you don't have to switch any of your infrastructure. Like, you can still enable steam, for example. But it has a cost in terms of the amount of electrical load, and it might not even be possible to get from the utility. So there's all those sides that the electrical team is helping clients understand, which I think is really important work. Did that sort
Yeah,
of answer your question? Happy for follow-up if you have any others. And also happy to get that question to Jared too, so he can put his 2 cents in after the fact.
yeah. The only piece I'll add, Dennis, is I do think, our master planning team coupled with the decarb team, as they're preparing these reports and doing these studies and talking with clients on their end, they're doing a good job of educating them as they're doing the planning phases as well, which, certainly helps as they continue to look forward to funding and figuring out an actual project.
Yeah, one of my favorite things about my job is that this ability to help bring clients along, because I think another challenge of decarbonization is the people who are at the table are different. All of a sudden you are going from talking to maybe a facilities operator or manager who might, have some semblance of how systems work. And all of a sudden you're going to finance or the board of trustees who have, like, literally no clue how their campus operates. And suddenly you're having to describe this idea of COP to them and why that's so helpful. So I have a lot of really weird, silly stories under my belt to help just tell a story that anybody can sort of pick up and run with, which is a really helpful tool to have in our belt. But I will say too, I've received the feedback that even the facilities managers might not know how this stuff works now. The folks that were used to being able to just transparently talk about equipment because this technology is new. So, like, even some of them haven't come across anything beyond operating a steam boiler. So there's a lot of education that's happening. And that's I'm passionate about that in this work. I would just be curious if you're okay with it, Hannah. Like, how did you approach all of that research and gathering the data? So were you literally, like, going on their websites to grade how well the utilities aligning with the state goals, or how did you suss that out when you were doing that research?
From the state point of view, Jared actually gave us this really cool website that had a lot of stuff already compiled on it about
I love that, the one with the clickable states
yeah.
maps, and you can go right to the legislation. Yeah, yeah,
But for like the transmission providers and the utility providers, it was really just going on their website and
yeah.
seeing did they have a plan for, decarbonizing in the future? Did they have anything listed about upgrades they wanted to do on their system? and how they were even trying to like get off using fossil fuels. And most of the time it was pretty obvious to see if they had like a plan for it because they would have a little tab that was like sustainability,
Got
and
it.
other companies would not or not have examples of that. So
Yeah. So you were looking to see if they had their own sustainability goals published and then probably reading their plans to see how real they were, like, because there's plenty of sustainability plans that corporations can publish that are pretty greenwashy, like we're going to recycle that side of things, and then it's different to have your reduction goals. Did you run into that at all?
yeah, especially when it came down to like utility providers, we saw a lot of like with the transmission providers, they all had this focus specifically on like getting off greenhouse gases and using other sustainable methods, where when you went to utility providers, their definition of sustainability was more of like keeping stuff up and running rather than like
Yeah, different views of the
yeah.
word. Can you help me understand the difference between the utility and the transmission service a little better? I'm new to that.
Um, from what I know,
You're better than me, I
transmission
can tell already.
transmission provider is more of like bigger scale. Sometimes they cover a couple states, sometimes they don't. Utility provider is a little smaller scale,
Got it.
more like
Okay.
specified.
Okay, but great
Yeah.
that you included both in your study.
So to help Hannah out a little bit, yeah, transmission providers, there's probably about 6 or 7 throughout the country that manage the overall transmission of power. Some of you know, there's PJM, there's ERCOT down in Texas. You know, there's I forget what the Midwest one is, but they're the ones that are dealing with interstate power transmission and largely going across the state lines. And then you get down to utility provider, which you could have multiples per state.
Yeah,
That's your BGE, your Pepco, your your Duke and stuff like that.
yep,
So that's the main difference.
got it. I got some homework to do. I want to check out who those 7 are. Make sure I understand who the Midwest one is, because that's where I am. Great. Thanks for clarifying that, Andy and Hannah. And Hannah, thanks again for jumping on and answering my questions and for all your work. And I think hopefully I'll be able to be helpful in making sure that data gets published internally and we share it. But congratulations on that.
Thanks.
Yeah. Any other questions or comments from the group? Well, it's 12:56. I'm gonna give you 3 minutes of your lunch break back, but thank you so much everyone for joining us today and for bearing with us while we got Jared back on the road. Andy, thanks so much for stepping in and helping with Q&A. I really appreciate it. Have a great day, everyone.